How does cryovolcanism work on Triton's surface? Imagine a world so cold that instead of flowing lava, it spews icy plumes into the sky. That's what happens on Triton, Neptune's largest moon. Instead of molten rock, it erupts with icy substances like nitrogen, methane, or water. But how does this icy volcanic activity actually work? Let's find out. Triton's surface is mostly covered with frozen nitrogen ice, which is extremely cold. Beneath this icy crust, scientists believe there are layers of warmer, possibly liquid materials. These layers could include a subsurface ocean or warm ice that can melt or turn into gas. The key to cryovolcanism is the movement of these volatile ices from below to above. The process starts when internal or solar heating causes the ices beneath the surface to melt or sublimate. Sublimation means turning directly from solid to gas without becoming liquid first. Sunlight can penetrate the translucent ice, warming the material underneath. Internal heat, possibly generated by gravitational forces from Neptune pulling on Triton, can also raise temperatures inside the moon. As the ices warm up, pockets of liquid or gas from under the surface. These pockets build up pressure as more material melts or sublimates. When the pressure becomes too much for the surface to contain, it forces its way through cracks or weak spots in the ice crust. This causes icy plumes or geysers to erupt into the thin atmosphere. These eruptions deposit fresh ice on the surface and create new landforms. They also keep the moon's surface constantly changing, even from the sun. Observations have seen plumes rising about 8 kilometers above Triton's surface. These plumes are thought to be made of nitrogen gas and ice particles, carried by weak winds across the moon. Scientists believe these plumes could come from nitrogen melting due to sunlight, from internal heating, or from cryovolcanic outgassing from reservoirs deep inside Triton. The presence of active plumes suggests Triton might even have a subsurface ocean or layers of warm ice that are still deforming and moving. Understanding cryovolcanism on Triton helps us learn about other icy moons and planets in our solar system and beyond. It shows that even in the coldest places, geological activity can still happen. This activity hints at the possibility of hidden oceans or warm layers that could, in theory, support some form of life or at least give us clues about planetary processes from Earth. So, in simple terms, cryovolcanism on Triton works by heating icy materials from below or through sunlight, building up pressure, and then erupting as icy plumes that reshape its surface. It's a fascinating process that reveals how dynamic even the coldest worlds can be.